Welcome to part one of Prompt and Policy's AI Beyond LLM series, where the goal is to walk you through some of the fundamentals of AI. The sort of theme of today's video is to examine some of the different types of AI that we're interacting with in our daily lives. So let's begin with one of the most common types of AI, which is called predictive analytics or predictive AI. Predictive analytics is basically the use of statistical methods to sort through big data, vast amounts of data in search of patterns. And this can enable things like forecasting and prediction, and is used in both in the marketplace and the policy and public policy programs. When we ask, why does it seem like everyone is all of a sudden drinking matcha, or why everyone has those Stanley cups, it is in parts because the recommendation algorithm is very good. Recommendation systems, which are a form of predictive analytics, are found in all different types of applications, like Netflix, for instance. When you've been really into watching action films lately, Netflix uses recommendation systems to kind of help suggest other types of videos that would fall either into that category or perhaps be similar to your interest in action films. And recommendation systems tend based on two main types of filters, which are content filtering and collaborative filtering. And Amazon, for instance, has used something called collaborative filtering for its own product recommendations, and that has kind of been iterated over time. The way it kind of works is it looks at users' purchasing histories, and it matches those purchasing histories with users that also have similar purchasing histories. And from there, that's kind of combined to predict what other types of items you might be interested in buying. There's also another type of filtering called content filtering, which Spotify uses also in combination with other filtering that kind of keeps in mind what a user finds interesting by using information retrieval based on the user's accounts in combination with like other metadata. So depending on how long you've listened to a song, your listening history, your playlist, all of this is combined to recommend perhaps the next song you should listen to. In addition to recommendation systems, there's something called ranking systems, and ranking systems are what we on social media platforms. That's how our news feeds are curated. And ranking systems basically place posts or content of orders based on things like how much likely to engage with the post, for instance. But predictive policing can also kind of have a less glamorous path to things like poor implementation. It's agencies that are using predictive analytics to forecast different types of scenarios. They're using that in combination with their own employees' insights and knowledge, triangulating the data, looking at patterns of whether there might be more threats to certain different types of infrastructure or by certain groups of people. And so I think ultimately, when it comes to predictive analytics, it really depends so much on the type of implementation, how we're thinking about its use case in general, how we're defining our problems, and matching a tool like that to the problem definition. And it really also depends on ensuring that, the caseworkers or the people using those tools when it comes to public policy, for instance, aren't completely dependent on the tool to ultimately make their decisions, that it's something that's kind of adding an additional insights or forecast to other aspects of decision making. Another common type of AI used on a regular basis is called generative AI, and it's really come to the public attention since 2023 with the advent of ChatGPT. And what really distinguishes generative AI is its ability to generate new content in terms of text, videos, or images. And I think it's also important to note that the three kind of main architectures behind AI foundational models are transformer models, diffusion models, and GANs. Because, for instance, something like the transformer model is really what makes the ChatGPT the ChatGPT. And a transformer model can also be applied in areas besides text generation, like computer vision and speech recognition, when it's applied in this sort of large language model like setting, it basically enables the large language model to predict the correct response to a prompt based on this concept called next word sequencing. And ultimately, that capability is really what makes LLMs so convincing because how they're built. So rather than being information verifiers, LLMs are next word sequence predictors. And because they're trained on vast amounts of data from the internet, they're also able to respond to a prompt in a really confident way. However, that confident response can also contain inaccuracies, and that's sort of just inherent part of the LLM because the examples of its given in trained data are something like how do you form a well-worded argument? And the examples for how to form a well-worded argument are often very confident. So it kind of mimics that predicting the next word in a confident way because of the way it's built. Now, transformer models are not the only type of architecture underlying generative AI. There's also something that's kind of a newer class of models called diffusion models. And diffusion models are kind of are being associated with breakthroughs in scientific discovery. The DeepMind's AlphaFold 3 based on a diffusion model, for instance. And kind of one of the key takeaways about generative AI is that ultimately all generative AI hallucinates, which means that it provides inaccuracies. And that's just due to the inherent makeup of the generative AI. And while there are a few methods being explored that kind of can help reduce these inaccuracies, such as RAG, at the moment there's really no perfect solution to that. Next form of AI we're going to cover is called conversational AI. And this can be a bit confusing in that conversational. And there's also a lot of similar terms that are thrown around when it comes to conversational AI, such as AI assistants, voice assistants, chatbots. They're all in this category. But really, what distinguishes something like a ChatGPT chatbot is that Siri and Alexia fall more into this traditional AI category, where they're really based on a set of predefined rules within logic. And that's why they're kind of known as being dumb as a rock, because respond pretty well to a very short task-oriented question like, what is the weather? But if the question becomes a bit more complex, or if you don't word the question in exactly the right way, then the Alexa or Siri might kind of stumble upon its answer. And that's perhaps why Apple just announced a recent partnership with Google's Gemini to kind of create a newer version of Siri that is integrating this sort of generative AI. Now, it's important to note that AI assistants and these type of general chatbots should be differentiated from something called AI companions. And while AI companions are a form of chatbot, what really makes them different is that they are designed in a specific way with something called empathy models. And that makes their interaction with the user very friendly, very empathetic, very understanding. And this can lead to forming quite an intimate relationship, the digital chatbot and the user. And that's why in the news lately, there's been a lot of controversy around companies like Character AI or Replicate AI, which kind of specialize in allowing users to make different types of personas like boyfriends, girlfriends, superheroes. There's AI therapists. And especially in a culture where oversharing is encouraged, the more people are starting to share these very personal details about their lives, seeking the AI for these sort of very intimate or therapist-like answers, and the AI in return is able to give quite a long form response. It kind of creates the illusion that the chatbot is something that it is not, because ultimately the chatbot doesn't understand contextual nuances, or nor is it really able to completely remember from its experiences, especially in the same way that a human. And once again, what makes this persuasion of an AI companion so convincing is this ability of the LLM to provide a sort of dense information-packed dialogue with the user, even if the information is not always accurate, and even if it really is not in the capacity to respond properly to questions that the user might be asking. Now it's important to cover something called agentic AI, and agentic AI is different from AI assistants and from AI companions. The way we can define agentic AI is really through its more proactive behavior. And agentic AI is able to sort of go out and interact with its environment and achieve a set of goals and sort of a step-by-step process with the use of tools. So while an AI agent is an LLM, where the LLM kind of acts like a brain alongside tool use, we are seeing that it's kind of moving away from this just basic text prediction capability of a normal LLM towards this step-by-step implementation and different degrees of reasoning. However, ideally, it's still the human who's supposed to be setting the goals and the overall rules for the agents and the boundaries, even though the agent does contain the ability to make autonomous decisions. And sort of one of these is that when the AI agent realizes it's missing knowledge, it can tools like web search browsers, access external databases, and even coordinate with other agents to find missing information on its own. So to kind of conclude, LLMs are generative AI, but not all generative AI are LLMs. And AI agents combine generative AI with tools, but generative AI alone is not agentic in that it is dependent on prompts to kind of move forward. There are also areas of AI like computer vision that enable things like facial recognition or are used in autonomous vehicles. There's also areas like robotics, which we're really not going to cover today. You also did not go into any of the technical details of these AI models like deep learning, neural networks, machine learning, supervised versus unsupervised learning. I hope that you find it useful to kind of have this broad overview, understanding that on a daily basis, we are using different types of AI, how those different types of AI are useful in different cases and in different contexts. And I think one of the main takeaways to think about how landscape for the way in which we acquire different sources of information is changing. We should really try to perhaps balance the to maybe go ask an LLM for what we might consider to be an expert opinion, for instance, rather than talking to a human that might have years of lived experience or tacit knowledge on a subject. Because ultimately, this starts to become a question of how we are starting to divide our lived experiences amongst the artificial and the natural world. And that's going to be a pattern that's different for everyone.